Today, I'm going to show you how to make your 3D scene look like it was drawn with colored pencils. Let's go. Alright, so we're in the middle of a series of videos on building custom lighting models. And by custom lighting models, I mean using the graph to alter the way the lighting works. If you haven't seen the previous videos in the series, I'll post a link to the whole series of videos down in the description. Instead of using the realistic looking lighting that the engine provides by default, today we're going to make lighting that looks like it was drawn with colored pencils. The first thing that we need to do is make a texture that looks like this. This is a cross-hatching pattern, and what I've done is make a set of 16 images where each image takes the previous image and adds more lines to it. The images are tiling so they can repeat without seams, and I've arranged all 16 images into a single row and put them into one image just like this. In the engine, I can turn this image into an array texture and then use the brightness of the lighting to select which slice of the array to sample. If you're not familiar with array textures, it's basically like a big stack of textures where you can sample once and tell it which of the textures in the stack you want to use. So in our case, we're going to use the brightness of the lighting to determine which of these 16 textures that we've got lined up here we're going to use depending on how bright or dark the lighting is. Alright, so let me show you how I made this image that looks like a gradient from bright to dark with these accumulating cross-hatching lines. I used some software called Substance Designer, so we'll switch over to Substance Designer here. And what I've done is I've just added this noise called Gaussian Spots 2, and then I've applied a levels to it. So this is what Gaussian Spots 2 looks like. Then I've applied levels to it to adjust the brightness of the spots. And then I've inverted the image so that I've got white with just a few black spots instead of black with a few white spots. And then I used a node called Directional Blur to blur the dots in a specific direction. And here I've got an angle of 154 degrees. And so I've blurred these with an intensity of 25. And then I used the levels node to adjust the brightness and contrast of those blurred lines. And my levels node also changed the resolution. So here I've been working in 2048 by 2048. And then when I got to here, I cut the resolution using these image size controls here. So now I have an image that's just 256 by 256. And the really nice thing about using Substance Designer is that most of the patterns that it has will tile. And so I get tiling for free. So if I toggle on this repeat here, you can see that the image tiles without any seams. And that's important for my scene. Okay, so this was the base pattern that I used. And then I just duplicated this pattern over and over and over. So let me show you what I've done here. So I've taken this row here and just copied and pasted it a whole bunch of times. 16 times, in fact. So I've got 16 different patterns. And what I've done for each of these is, for the Gaussian spots, I added a different value for disorder. So each of my spot patterns is going to be different. And then I also set a different direction for the directional blur. So if we zoom out here, you can see here's my first image. Here's my second image. Here's my third image. These are all going in different directions. And then I've used the blend node over here set to multiply so that each of the images accumulates on the last one. So as we go down the line here, you can see I'm multiplying more and more and more and more cross-hatching lines so that it just gets darker and darker. And you can see if you look here, there's a really nice gradient from the brightest one down to the darkest one here at the bottom. Once I'd done all that, I saved out each individual image that had been generated. So I've got a set of 16 cross-hatching lines where each one is a little bit darker than the last one because it's adding its own set of lines that I've created here. So I saved all of those out as individual images, and then I opened them in Photoshop and lined them up into a texture like this. So at this point, nothing that we've done is software specific. We could use this for Unreal or Unity. But let's take a look at Unity first, and I'll show you how I brought these in and then how I built the graph to make my image here that looks like it's been drawn with colored pencils. Okay, so what I did is I imported my texture. Here's my image called Pencil Array 1x16. I set the texture shape to 2D array, and then I set it to columns 16 because I have 16 of those 256 by 256 images all lined up in a single row. So I made column 16 and rows 1. Then I turned off sRGB. I set my texture format to R8, which means I only have a single channel. It's a black and white image, and it's an 8-bit image. Then if we take a look at our preview down here, because I've set my texture shape to 2D array, I can actually scan through all of the different slices of the array with this slider here. And this allows me to see, you can see the first image is just completely white. And the reason that it's showing red here is because it's a single channel. All the data is stored in the red channel, so it's showing red. But really, this is just black and white 8-bit data. And I can select all of the different slices of the array. And you can see that slice number 15 is white, and slice number 0 is the dark version. And the reason that I set it up this way is because when my light is black, or 0, I want it to sample slice 0, and when my light is white, I want it to sample the brightest slice, which is slice 15. Now, you can set up whatever type of image you want. And in fact, if we switch back to Photoshop here, you can see that I also set up another image that is a stipple pattern. So this one just has like random dots that accumulate on themselves. You might also try different kinds of experiments. In this case, I wanted it to look like it had been rendered with colored pencil. But you could also do different types of cross-hatching or different types of stipple patterns, whatever kind of image you want, or whatever type of shading you want to use, you can imitate that in these gradient images and then bring them in and come up with a lot of different styles of lighting. So we're doing colored pencil lighting today, but depending on what kind of image array you create, you could create magic marker. You could create something that looked like it was done with a ballpoint pen, all kinds of different styles just by building an image array like this. All right, well, let's go ahead and create the shader, and I'll show you what the graph is doing in order to sample this array and render our scene like this. So what we're going to do is come over here to our lighting folder, and I'm going to find our basic lighting. This is the cheapest form of lighting that we created in a previous video. If you haven't created this basic lighting subgraph, check the playlist down in the description. There's a big list of all the videos in this series, and one of them is specifically about how to create this basic lighting. All right, so I'm just going to copy and paste this basic lighting subgraph. And instead of basic lighting, we're going to call this pencil lighting. And then We're going to come in here to our lit subgraph where all of our lighting models are kind of stacked up here. And I'm going to grab my pencil lighting and drag it in. And we're going to connect up pencil lighting in here, just like all the rest of our lighting models. So we'll bring in our base color, our normal, and our ambient occlusion. Then we'll hook up pencil lighting to the output of the graph and save it. And then we'll switch back to our scene, and what you can see now is we've got our standard lighting back the way that it was because we just made a copy of basic lighting. So now we need to adjust our pencil lighting subgraph so that we get the behavior that we want for our pencil lighting. So here we got our diffuse lighting, we've got our additional lights, we've got our ambient lighting, and then we're combining things together here at the end. And what we're going to do is move these nodes out of the way so that we can make some additions to our graph right here. So let's go ahead and do that. What we need to do is bring in our array texture. So I'm going to grab our pencil array 1x16 and just drag and drop it in here. And let's set up our UV coordinates first because that's easy. I'm just going to take our UV coordinates and we're going to multiply these by 3. So I'll just add a multiply node and then multiply our UVs by 3 and connect them up just like that. And now we need to determine the index value here. Remember I said, like, if I type in an index value of 15, we get the white version. And if I type an index value of 0, we get the dark version. So I need to create that index value between 0 and 15, depending on how bright our light is. Well, we have our light coming out right here. And so I'm going to take our light and add a saturate node just to make sure that our values get clamped between 0 and 1. And then I'm going to desaturate it, meaning I'm going to suck all the color out so it's just black and white. And I'll do that with a saturation node. So there's my saturation node, and I'm going to give it a saturation value of 0. Okay, because we don't want any saturation at all. And then, now that it's a black and white image, I'm going to add a swizzle here and just use a swizzle X so that I'm just sampling the first channel. This ensures that the value coming out of here is a float instead of a vector 3. All right, well, let's move our array texture out of the way here because we need to do a little bit more in order to generate the 0 to 15 value that we need. The first thing that I'm going to do is just adjust these values a little bit. I'm going to add a power node and raise this to a power of 8 just to really crank up my contrast. And this is something that you can tune to get the results that you want, but I'm going to leave that at 8, and then once we get our final result, I'll come back here and tweak it a little bit and show you what the differences are. Okay, now we have a value that is between 0 and 1 based on the brightness of our lighting. But we need it to be between 0 and 15. So I'm going to multiply this by 15. And now I want there to be a hard line between each of those integers. I want it to go from 0 and then to 1. I don't want there to be any gradients in between. And the way that I can do that is with a floor node. So I'm going to add a floor here. And that will round down to the nearest integer. And so right now, after I've done this floor, what I'm going to get is 0, 1, 2, 3, 4, etc. all the way up to 15, instead of having a nice smooth gradient like I had here. I don't know if you can see that very well. Let me just skip to this power node for now, just so that we can get better previews. Here you can see we've got a nice smooth gradient. But once we add the floor node, now we get hard values. And I know that this looks like it's just black and white, but there's actually a whole bunch of hard values in here. Let me just skip this multiply by 15 here. Actually, that's not going to work. If we we've multiplied by 15. If we now divide by 15, you'll get to see all of the different gradients. Yeah, there's a couple of different gradients that you can see. Yeah, okay, there you go. That's a good preview of what it actually looks like, where each of these slices here is a different integer between 0 and 15. And so now I can take that floored value that's an integer between 0 and 15 and plug it into our index. And what that's going to do for us is it's going to use the brightness of the lighting to choose which slice of our array texture to use. And so now coming out of here, I've got a nice cross-hatching pattern that I can use in my scene. So if I just plug this directly into my output, let's take a look at our scene and see what we get. So I'm going to save this and switch over to our scene here. And now you can see I've got a scene that is just a bunch of pencil marks. And that's pretty cool, but we need to do a couple of things to make this feel like it's done with colored pencil. You can stop here if you just wanted to make it look like it was drawn by a graphite pencil, but we're going to make it look like it was done by a colored pencil. So let's go ahead and do that. Come into our pencil lighting here. First thing that we're going to do is take our scene and we're going to multiply it by the base color, and that's going to introduce color back into the scene. But we need to blend between what's colored pencil and what's the color of the paper. So I have a color value here, and this is the color of my paper. You know, you can use whatever color you want, but this is the color value that I chose. So we need to lerp between the color of the scene and the color of the paper. And so I'm going to add a lerp node here, and we'll lerp between the scene color and the paper color, and we're going to use the value coming out of our array texture to determine that. So I'll just plug this into this lerp here, and now we can plug that value into our output, and that's going to give our final result. So let's just clean up our nodes just a little bit here, make our graph a little bit more tidy. So there's our paper color. There is the color of our pencil marks. And we're using this mask that we've generated with our array texture to determine what color to use. All right, so we'll save it and switch back to our scene. And now we've got our colored pencil effect. So that array texture is determining if we're going to use the regular color of the scene or the paper color. And we end up with this really cool looking pattern as though our scene were drawn with colored pencil. Now, like I said, the pattern that we chose to create today was kind of that cross-hatching pattern where it built up upon itself. But you can also create all kinds of different patterns. You can do ballpoint pen, you can do magic marker, you know, whatever you choose, and just create a pattern like this. And you can create a scene that looks like it's rendered with all kinds of different drawing implements, pens, pencils, even paintbrushes if you wanted to. So this is a really cool way of creating a non-photorealistic rendering method that you can do all kinds of different things with. Now I did mention that power value, so let's come back in here. Right now we've raised it to a power of 8, but if we just set it to 1, you know, we can get different amounts of contrast in our scene. And this might be something that you want to add on a slider and dial it in and do lots of tests. You know, I think a power value of 1 ends up with a scene that's a little bit too bright, which is why I increased it. Here's what a power value of 4 would look like. And this is something that you can play with to get just the tuning amount that you're looking for in your particular scene. All right, well, that's how you do it in Unity. Let's switch over to Unreal, and I'll show you how to do the same thing in that game engine as well. All right, here we are in Unreal. And you can see, just like we did in Unity, we've got our colored pencil style rendering going on here. The first thing that I want to do to show you how this is achieved is show you how to create an array texture. So here's the array texture that we created. And the way that I did this is I'm going to open my content drawer here, and you can see that I've got each of the individual slices of the array, and I brought it in. So I've got 0, 1, 2, 3, and each of these builds on the others by adding additional cross-hatching. And Unreal is a little bit different than Unity in that instead of bringing in one image with all of the slices lined up in a row like I did in Unity, what I've done in Unreal, and the way that Unreal expects you to make array textures, is by bringing in each of the individual slices and then building an array from that. And so the way that you create an array texture is you just right-click in here in your content drawer, and I can come under Textures and pick Texture 2D Array. So that's what I did. So here's my Texture 2D Array that I created. And what I had to do is, it was empty when I started, but I had to add all of the images of the array. If I come here under Source Textures and open this, you can see here are all of the images. So I had to hit this plus button here to add 16 array elements. And then you can see they're numbered 15 through 0. And I've done them in reverse order. So I made the darkest one first, all the way up to the brightest one. Now, a couple of things that you should know about making array textures. All of the images, all of the slices of the array, all of the individual images have to be the same compression format and the same resolution. So they all have to match each other. If they're different, the array won't work correctly. So make sure that when you import all your individual images, like I have here, that each of these images is the same resolution. All of mine are 256 by 256. And that each of them is also the same compression settings. All right, so there's my array. I've got 16 different slices in there. Let's go ahead and take a look at our shader. So I made our material function called pencil lighting just by cloning the existing lighting model. So here's my simple lighting. In my lighting folder here, I just cloned basic lighting and I named it pencil lighting. And then just like we did in Unity, I made the same adjustments there as I made the same adjustments here as I did in Unity. So basically what we had before is coming out of multiply. This was just wired directly into our output lit like this. So this is what it used to look like. And what I've done is I've taken the lighting. Here's my diffuse lighting here. Actually, you know what I need to do? I need to take the lighting coming out of this add node here and wire that into saturate. I think that may look a little bit better in our test scene. Well, I suppose that's up to you. I actually think that looks a little bit worse, but there are lots of different options here. We could just do directly with the diffuse lighting itself, which looks like this, or we could go with the diffuse lighting added together with the multiplied by the light color and then added with the ambient color. This is really up to you in how you decide to combine all of the different lighting components. Okay, but I took the lighting and I saturated it, and then I added a desaturate node, and for the fraction I plugged in a constant of 111. And what that's going to do is remove all of the color from the image so that it's just black and white. And then I masked out just the red channel, because once you get black and white, you want to make sure that you're only dealing with one channel and not three. It makes all of the math that comes after a lot cheaper to just do things on one channel than all three of them. Then I raised it to a power of 8. And just for now, let's set this to 1. You can see I've got my nice crosshatch shading going on here. and then I multiplied it by 15. And this is because we're trying to create an index value that's going to sample into our array texture here. The array texture needs an index value to know which of the slices of the array to sample. And there are 16 slices, and they're numbered 0 to 15. So I have to provide this with a value that's 0, 1, 2, 3, up to 15, so that it knows which slice to sample. And I'm using the brightness of the lighting to determine that. So I'm multiplying by 15 and then rounding down to the nearest whole number with this floor node here, which gives me a value of 0, 1, 2, 3, 4, etc. All right, now I take my texture coordinates and I'm multiplying these by 6, but you can obviously set this multiply to whatever you want it to be, depending on how large you want your pencil lines to be in your shading. So I take my texture coordinates and I append the index value. So this append node is creating 3 values. It's the U and the V coordinate and then the index value combined in the third channel. So I append those together and pass them in as the UV coordinates for my texture sample. And then my texture here is sampling my pencil 2D array 16 image that I created. All right, so if I wire this directly into my output, now you can see I have a nice gradient here where around the back of the sphere I have my darkened section of the array, and then around the front of the sphere I have the brighter section. Okay, and then I just took the graph as it was. So like I said, if I wire this directly out, this is what I used to get with the basic shading. And I took that and I lerped between that color and the color of my paper using my array texture as a mask. So this is what I'm going to end up with here. And if we save that and switch back to our scene, now you can see we've got a nice looking colored pencil renderer going on in Unreal. Well, let's go ahead and tune this just a little bit. Maybe we'll go back and raise it to a power of 8 again. And save it. Yeah, that looks pretty nice. So you can see we're getting those nice dark colored pencils lines in the non-lit side, and then in the lit side we're getting a little bit more like brighter values and the colors of the paper in between the lines. All right, that's pretty cool. And like I said, you can use this for all kinds of different styles of rendering. If you just create different, switch back to Photoshop here. If you just create different kinds of images here with different patterns, obviously all of them need to be nice gradients between the brightest and the darkest. But you can create patterns with all kinds of different drawing tools to create all kinds of different styles. All right, I hope you enjoyed today's video. Thanks a lot for watching, everybody. Have a great week, and we'll see you back here next Thursday.